Now I'll introduce our speakers. We have Renn Lambert and Joshua Hortin. Renn is an environmental engineer with LimnoTech, and then Joshua is a professional engineer intern with Hansen and Allen and Luce engineers. So I'll turn the time over to you guys.
Awesome. Thank you. It's good to be presenting the results of the study to you today. So I'm Josh. We had the opportunity to work with Renn and LimnoTech. We paired together to do this study for the state. Yesterday, Laura Vernon gave a presentation about the Great Salt Lake Basin Integrated Plan, and she showed a slide with 8 projects that are being funded under the funding available. This is kind of like the 9th project that is feeding into this Basin Integrated Plan. The difference with this one is that a question came up a little bit earlier, and the legislature went ahead and set aside a little bit of funding to answer this question. So while those other 8 studies are ongoing right now, this one is completed and is feeding into that plan. Now, I want to poll the audience real quick. We're talking about low impact development today. It's sometimes called green infrastructure or better site design. If you've heard of one of these terms, can you raise your hand? Wow, that is great. It looks like we've got some good penetration of that term into this audience. Now, question 2, a little more in depth. If you can visualize an example of what LID is, or if you've seen one out in your communities, can you raise your hand again for me? Great. That's also good knowledge. If you didn't raise your hands on one or both these questions, no problem. That's what we're talking to you about today. So low impact development is actually, it's not one single thing. It's a group of techniques that we can use to kind of mimic the natural environment when we develop. So if you imagine a plot of land in our pre-development scenario, there's native plants on that land. When it rains on this land, very little runoff is generated. Most of it soaks right into the ground, and most of it actually stays within that top layer of soil, the top 3 to 10 feet or so. Doesn't go to the deep aquifer, but it stays there, it's used by the plants, eventually it evaporates. Once we develop, now this is kind of a traditional development here, lots of pavement, lots of impervious surface. So a lot of runoff is generated, and our main concern has been flooding. So we've built pipes to carry away that stormwater, maybe take it to a detention basin where we can kind of slow it down and release it to a water body more slowly. But development with LID preserves some pervious area and allows that water, instead of being piped somewhere else, to infiltrate or be treated on site. This has a number of advantages we'll get to, but as I mentioned, there's a number of techniques, even starting with just thinking about how you're designing your site to minimize your impervious area. We've got harvest techniques, infiltration devices, vegetated basins. Some of these examples are shown here. Now, they can go from very simple to very complex. For example, here we've got just a shallow grassed slope. This parking lot right here doesn't really have a curb. With an LID technique, it could still have a curb with maybe some cuts to allow stormwater through. But what happens here is as stormwater flows from this parking lot carrying pollutants, the grass kind of slows it down. It allows some opportunity to infiltrate, so some of those pollutants infiltrate, and they're treated by the soils and plants. And we could even have a pipe right here, the more traditional pipe, and carrying away the excess rainwater, but that's still been treated by LID. Now I mentioned a curb cut. This is an infiltration trench from a community in Logan. So the pollutants off the street will go into this infiltration trench, the water soaks in. Getting a little more complex, we can have permeable pavements, whether that's blocks with cracks to allow water to filter in, or just a permeable concrete. A lot of places without space to dedicate to LID are using these infiltration galleries. These domes get placed under a parking lot, and the water goes into these domes, and it allows it time and space to soak in. And this is a rain garden type system. It's not an infiltration device, so the water will flow through, but all these layers that are designed here will help remove some of the pollutants and treat them. And then the water will continue on to a waterway. Now, why does the state require LID? Well, it all starts with the Clean Water Act, helping to keep our rivers and waters cleaner. Under the stormwater section, communities of different sizes have been regulated over the years to have these minimum control measures to control post-construction or post-development runoff. So the state implemented these LID techniques in about 2020. And there are, though, benefits, not just beyond, well, it's required. I like these figures because they're both showing the same things, but from different perspectives. This really shows a lot of LID implemented. This shows kind of the impact on the aquifers. So we're keeping pollution out of our rivers and lakes and treating it with soils and plants. It allows our aquifers to recharge, and eventually the aquifers discharge to a water body. And often this is less costly than installing a big community system. So lots of benefits there. So with all these benefits, what is the impetus for the study? I'm going to turn it over to Renn here to talk about that.
Thanks, Josh. So yeah, there we go. Can you guys hear me? Okay, good. Yeah, so the purpose of the study was to study the impact of LID on the Great Salt Lake water budget. Like Josh mentioned, the state regulations specified that new developments need to implement LID going forward. And there were some folks in the legislature, like Josh mentioned, that were interested in knowing what the impacts of those regulations are on the water balance. So that was the purpose of the study that we did last year. We finished it last November. And to go through the methods a little bit of what we did to do the study, first we wanted to just go through the water cycle of the basic water cycle of this watershed. Water hits the mountains. Most of the water, that's where most of the water comes from that infiltrates into the aquifer. LID would generally be implemented in recharge areas. So like in the valley areas, if you have a new development here where we have our LID infiltration specified, a subdivision or something, or a parking lot would be built with LID that infiltrates water into the ground. And it would join into the aquifer, some would evaporate, and then eventually go down to the discharge area. For this study, we assumed that no LID would be built in the discharge area because that's generally where the groundwater is really high. It'd be hard to infiltrate it in. But that's where the water comes back up and joins into a water body or is taken up by plants and evaporated. So this map shows areas in those recharge areas that I mentioned, the dark blue does, that are likely to develop in the next 40 years. So compared to the entire Great Salt Lake Basin, it's not a very big area. A lot of areas like in this valley and Utah Valley are already developed, but there are some places that are expecting development, like on the west side of Utah Lake, Tooele Valley, and a little bit up in Box Elder and Cache Valleys. And so in order to quantify the impact of LID, we developed two models. The first one was a surface water precipitation, runoff, and infiltration model, where we looked at how much water would go into the ground versus runoff with and without LID. And we also looked at a pre-development scenario as well.
And then output from that model, the infiltration down to the groundwater was fed into a groundwater model. And as you can see, this falls near the edge of the mountains because it's just in the recharge areas. Down in the lower areas is the discharge area. So we assumed they wouldn't implement LID there. We fed it into the ModFlow groundwater model and simulated the water flowing through the aquifer back down to the discharge area. And we looked at, with and without LID, how much water would make its way to the Great Salt Lake. And now Josh is going to talk about the results from that work.
All right, so this is kind of a flow diagram. So if you think back to your plot of land, right, it's undeveloped, we've got native vegetation there. So as I mentioned earlier, most of that rain that falls on, the vast majority of it is infiltrated. A little bit makes it to the groundwater, the deep groundwater, but most of it is uptaken by plants and eventually evaporates before it gets to the Great Salt Lake. There's very little runoff from this scenario. So about 9% of the water will make it to the Great Salt Lake, the majority of that going through the groundwater. Now, if we assume the same plot of land is developed without LID, we generate a lot more runoff here, which you can see. Now, we assume that all that runoff makes it to the Great Salt Lake, goes right into a water body. We need to put a little bit of an asterisk on that because what we didn't, it was outside the scope of the study. We didn't consider what alternative water quality treatment you need to do. You can't just put that water right into a river. There will be some losses to evaporation in that treatment. We can also see that our infiltration got reduced and our groundwater recharge got reduced in this scenario. But one notable takeaway is a lot more water from the stormwater portion makes it to Great Salt Lake. With LID, you can see that that runoff is converted right into infiltration. So we maintain about the same level of infiltration overall. Our groundwater recharge goes way up because that stormwater is concentrated into one area where it can reach it has more pressure pushing it down towards the aquifer. So it's really, we're showing that more water gets to Great Salt Lake with future development, regardless of whether traditional or LID techniques are being used. It's just that the route changes a little bit. With LID, more goes through the groundwater. So we get that benefit of the aquifers being recharged. Now again, this number reaching the Great Salt Lake, it's higher than pre-development. It is a little lower than without LID. Again, just consider that asterisk that we didn't consider losses from alternative water treatment. Now, you may wonder, okay, what is the contribution overall of stormwater? Well, it's pretty low. This is the annual inflows to Great Salt Lake. Stream flow from our 4 major streams makes up the bulk of it. Something I never really thought of until this study is rain falling on the lake. That actually makes up a very large portion of the budget as well. Our existing urban runoff, we're estimating, is about 7%. So with future development, with or without LID, is going to boost overall flows about 1%. And then an additional 1% possibly is the difference between LID or no LID in the future. Again, with that caveat of what the alternative water quality treatment does to those flows. I think the major takeaway, though, is that no matter what, from a stormwater perspective, development is sending more water to Great Salt Lake.
Yeah, so this is just kind of summarizing what Josh just said, the benefits and drawbacks of developing with or without LID. Like he said, development in the future will increase water to the Great Salt Lake. But if you develop without LID, it'll impair water quality. And without LID, you have less water to the groundwater. And you'll still require alternative ways to treat the water. You'll have to convey it, which can be very costly, have a place to treat it, maybe get into higher and higher levels of treatment as water quality standards are increased. So overall, the costs of going without LID are probably higher and more of a headache. And then with LID, you have improved water quality, increases to groundwater recharge. It does take the water longer to get to the lake. You will lose some when it comes back up into the discharging area to plants and so forth, but it's water that will be there in the future. If there are times of drought, the aquifer would be more recharged and that water would be available. Yeah, like I mentioned, increasing ET at the end, so a little bit less water to the lake with LID. But overall, it's not a big difference with the small area that's being developed and the overall size of the watershed. We're looking at a pretty relatively small amount of water with or without LID. So these were some thoughts we had after the study, observations and recommendations. Like I mentioned earlier, with no LID, you would still need to treat the water, which would be more expensive. We had some ideas for some future studies. These models could be used to quantify the water quality benefits. This was focused only on water quantity. So we're interested in knowing what the water quality benefits of the full build out of LID and future development is. You could also do a cost benefit analysis of future stormwater techniques with or without LID. There might be some places in the state where it would make sense to implement LID, and there might be other places where it might make more sense to do something else. So you could look at those costs and benefits. And then also regionalized planning. So along with the costs and benefits, looking at it on a maybe county by county or municipality by municipality basis and finding the most cost-effective ways to treat LID. And that's all we have. So if we have any questions, thanks.
Wait, is this on? Thanks, guys. I've actually read your report, so I'm delighted to. This helped clarify some things for me, some questions I had. And so I want to preface my question by saying that you guys know anytime you present a model, all your questions are going to be from people saying, well, why didn't you include such and such in your model, right? Okay, so that's my question. So you're basically comparing an undeveloped piece of land with a couple of different future development scenarios. Either of those future development scenarios also includes a water cost of development other than the rainfall, right? Because that future development is going to use water both inside buildings and on landscape. And so my question is really about that landscape water, because stormwater green infrastructure, LID, has an additional possible benefit, which is to offset irrigation water that you use on landscapes. So if you're using LID, that's potentially a bunch of irrigation water that would come out of your surface water creeks that could then stay in the surface water and go to the Great Salt Lake. So that was the question I had when I read your report originally. And I wonder if you guys have thoughts on that irrigation offset that LID can provide.
Do you have thoughts about that? Or?
Yeah, so that's a great question. I think my main thought, why wasn't that included? Basically, it came down to the scope of the study. I think that will be evaluated under the whole Great Salt Lake Basin integrated plan. But you're absolutely right. So when you look at these results, you have to remember this is just the stormwater portion. It doesn't include the future demands of the irrigated lawn, if they're basically how we develop in the future. There are other studies coming down the pipeline that will be looking at that type of question.
I guess this is kind of a follow-up question to her question, but looking at your approach, by constraining the benefits to just what is the benefit to the Great Salt Lake, or the groundwater aquifer for the Great Salt Lake, if that's the only cost-benefit metric, it seems like that's missing a lot of other, ecological services and natural resource services so at the point of the injection or whatever for the LID, it's supporting the regional aquifer there. If there's a creek running nearby, because development tends to strip natural areas of that groundwater component because it cuts off the pathway. So you're basically rebuilding those pathways. So if you're just looking and saying, oh, it's only really going to make 2% difference to the Great Salt Lake, so it's not that important, you're missing a lot of other really important areas that are also being benefited. And so I just was wondering, as in the bigger picture of how this is being handled, is that sort of stuff being considered, or is it kind of so tightly focused on the Great Salt Lake?
This study focused on the Great Salt Lake because that's just what they asked. Like I mentioned, I would like to know the water quality benefits, and I'm sure there could be more hydrological studies of how it could benefit the aquifers. And basically we just had a really short amount of time to do this, so we did our best to make our best estimate. We started the project, I think, in February and finished in November last year. So we developed the models and ran them very quickly without a lot of data, with our best professional judgment. And we were really lucky to have Hansen and Luce on the team because they knew the hydrology of Utah really well and helped us get through it. But yeah, we did our best to make an estimate and have a result for the state. But there are a lot of other questions that could be answered in future studies that I hope we can do. So.
Kind of the risks of overinterpretation.
Yeah, and we tried to put caveats in our report saying we did this quickly and this is a rough estimate and more work needs to be done in the future. So.
I understand the scope of the work and how that affected your research and your outcomes, but to be, I guess, fair to the rest of us and to the legislature, it would have been nice if in your recommendations you could have said something about all these other potential benefits of LID as opposed to hardscape. And I don't know if you did that, but it seems to me it should have been included.
Yeah, we did our best to include that. We did have a section on the benefits of LID, and we tried to push that. And I know water quality is too. So they're hoping that these LID regulations will stick and they can be implemented in the future. So.
I'm curious if you took into consideration, is it climate only as now or into the future as well? Because, projecting that there's going to be more rain events, are you considering that in the data?
Do you remember that?
That's a good question. I think we used current. LID says that you need to, the current regulations say you need to capture the 80th percentile of storms, which works out to be a ½ an inch of rain per event. So you need to detain at least that volume and size your LID to satisfy that. I don't think we adjusted that up per se, but if climate change just makes more frequent storms, then the sizing of that LID would be appropriate. If the storms get larger, then our LID is going to be a little bit undersized. So I think, though, that I can't give you the direct, I definitely remember this answer, but I think that we use current storm sizes
Yeah, I agree with Josh. We sized the LID to be for 1/2 inch of rain to capture a 1/2 inch event. So, and we assume that that would be this case in the future too. So,
Yeah, hi. Thank you for the really interesting thought process behind, if you use an LID with the consideration of the Great Salt Lake, that you might not be, generating all that water from your LID that's treated to the Great Salt Lake. That's just an interesting thought, because usually in practice you think that using an LID is really beneficial, and then you don't really think about, the losses that you could have. And that's sort of due to that infiltration that you were mentioning in that previous slide. But I was just wondering my background, I'm coming from Virginia, where we would use manufactured treatment devices to treat water quality. And you can connect that manufactured treatment device directly to your stormwater system, and you wouldn't have that loss of infiltration. I'm just curious if that was like a consideration, that could be like an LID that we could use, where we would still be getting treated stormwater without that loss of infiltration.
what kind of device is that again?
It's
Sorry.
called a manufactured treatment device, and essentially you can just source it from like a manufacturer. There's a bunch of different ones, like, I don't know, hydrodynamic separator, different options depending on like what types of contaminants you're treating for.
I see. And how does it get it down to the groundwater?
It would not.
Okay.
That was just a component that it wouldn't be recharged. It would just be treated. All that surface water would be captured in the MTD and then would be just connected directly to the public storm drain.
Oh, okay. I see. Do you have thoughts on that, Josh?
Yeah, I think we included or thought of those as kind of the alternative water quality treatments that we were alluding to. Although things like wetlands, not manufactured, but artificial wetlands would also fall into that category. But you're right. I don't know if I'm answering your question all the way, but those are ways to help clean the water, but wouldn't provide an infiltration benefit.
Right. And so I don't know if that was a consideration that, maybe that could be an option for an LID, but I also don't know if that's just a regional difference. I know in Virginia it's an accepted practice to be treating water quality. I'm just not sure if Utah has, considered an like a manufactured device, like a box that's placed to capture stormwater.
Yeah, I remember reading the manual that was released in 2020, and I think most of the LID techniques were focused on infiltration.
Right.
So that's kind of what we focused on, and DEQ signed off on that too for this analysis. So like we ignored the discharge area, but you'd have to implement something like that in the discharge area because you couldn't infiltrate in those areas, in the lower areas. So
Yeah, I think we'll see those types of techniques, especially in the discharge areas. I agree.
Thank you.
And then we're running out of time, so we'll do one quick question. And then if you have questions, just ask Josh and Renn after.
Thank you so much for your presentation. Groundwater is so important, and infiltration, especially in places like Provo, for example, that use mostly wells. For your model specifically, were you all the ones to create the model? I'm sorry if I missed that part. What program did you use for that?
So for the groundwater, we use ModFlow. The USGS has already developed groundwater models, so they're well established. They're freely available. That's what we used on the groundwater side. I'll let Renn talk about the surface water.
On the surface water side, we use EPA SWIM. So it's a surface water rainfall runoff model. It can do routing too. For this, we just did the rainfall runoff. So,
And those were more custom built, right?
yeah, we build them ourselves. So we couldn't find, we asked around, tried to find some kind of surface model we could use, and we didn't find anything. So we developed it ourselves. And our model just focused on the 4 largest counties, Weber, Davis, Salt Lake, and Utah County. So we didn't get up into Cache County and Box Elder for our portion. So
Perfect. Thank you so much.
yeah, yep.
Another round of applause for Josh and Renn.